All right, we're going to do a little bit of a review of Punnett squares. Some of you may remember this from middle school, some of you may not, so this is just a little help to maybe refresh your memory of what Punnett squares are. This is the most important slide in the whole presentation because this includes your vocabulary for everything you're going to see today. So you might want to stop the video, write this down, take a picture of this, whatever you need to do to help you as you move forward today. So basically, if something is homozygous dominant, that means homo means the same, dominant means we're going to use capital letters. I always use T's. You can use whatever letter you'd like to fill in Punnett squares, but if something is homozygous dominant, it's going to be represented with two capital T's. The dominant gives us the capital T. If something is homozygous recessive, we're going to use two lowercase t's. If something is heterozygous, we're going to use a capital T and a lowercase t. If something is purebred, it simply means that it is homozygous, meaning it's either two capital T's or two lowercase t's. That should say or, O-R right there. Let me change that real quick so it's not in here for good. So that should say O-R. And I'm also going to change pure or homozygous. And it doesn't specify here whether it's two capitals or two lower cases. It's just representing that it is purebred, meaning it doesn't have one of the alternate alleles in its presence. And then hybrid means it has one dominant and one recessive allele. Remember, if something is dominant, it's all capital. If something is recessive, it's all lowercase. Okay, so there's a worksheet out there that you may have seen in middle school that's called Bikini Bottoms Genetics, and this is where this comes from. And it says basically right here, for each genotype, which means these letters, tell whether it's heterozygous or homozygous. So on the next slide, it does that for you. So you basically put he or ho in the blank. So big T is homozygous, because it has two capital T's. But big B, little b would be heterozygous because it's a capital and a lowercase. Big D would be homozygous because it's two capital letters. Big F, little f would be heterozygous. If you're confused, remember on the previous slide, two slides back, I gave you the definitions. Homozygous would either be two capital letters, two lowercase letters. Heterozygous would be a capital and a lowercase letter, so you can remember it that way as well. Down here it says, what would be considered purebred? Well, I usually say all the hoes are purebred. So if anything with two big T's, two big D's, two little T's, two little D's, two little F's, two big B's, and so on, would be homozygous because it has the same letters. I know they're the same letters, but it's the same case of letters, capital, lowercase. The hybrids would be one capital, one lowercase. Heterozygous would be hybrids. So again, I don't know what you're talking about, Miss Smith. Go back 2 slides. Here's your vocabulary to help you. This will all make sense when we start doing Punnett squares. Okay, the next slide, it wants you to determine the phenotype. Pheno means physical. Physical appearance. Physical. Pheno-physical. For each genotype, which means sets of letters. This was vocabulary terms. So genotype would be letters. Phenotype would be physical. I don't know if it'll let me type on this without inserting a text box, so I'll do that real quick. So my genotype is going to be letters, which would be like big T, little t, or any sets of letters there. And my phenotype would be my physical appearance. What do I look like? Physical, just misspelled physical appearance. Oh, Lord have mercy. There we go. Let me make this a little bigger so y'all can see it. Let's get this baby spelled right. Okay, there we go. So genotype is going to be letters, and phenotype would be your physical appearance. So you're given right here, you're given the genotype, and it wants you to tell. Right here it says yellow body color is dominant. So my capital letter's dominant, and blue is going to be recessive. So if I'm big Y, I'll go ahead and click it ahead. Big Y is yellow. Big Y is still yellow because big Y is dominant to the little y. And the only way here that you can be blue is if you have two lowercase letters. If you look at the second example, square shape is dominant to round. Square is dominant. So if you see a capital letter S, then you're going to stick with that square shape. So capital S, square. Capital S, lowercase s, still square because capital S will dominate that lowercase s. And lowercase s is round. The letters are the genotype. The colors are the phenotype. Can I tell your genotype by looking at your phenotype? Can I tell your letters by looking at you? The answer to that is no. I cannot tell what you're carrying on the inside by physically looking at you. I don't know that you may be carrying something. I don't know that because I can't see your letters. I can only see what you're showing me. Like, for example, here, I don't know that this person is carrying a blue trait. I'm just looking at yellow. I don't know this person is carrying a round trait. I'm just looking at square. So genotypes and phenotypes are words you'll see come up over and over again. Okay, for this one, it wants you to give the phenotype. It wants you to give the look of this. For each pheno, it wants you to look at the appearance and give the genotypes. So it says a tall head's dominant to short. So it gives you the phenotype. It wants you to give the genotype. So tall can be two things because tall is dominant. It can either be big T, or big T, little t. Why? Because tall is dominant. And two letters always have to go together because remember, well, let me clarify. These letters come from mom and dad. So mom donates one of these letters, dad donates another one of these letters when making the baby. One comes from the egg cell, one comes from the sperm cell. Over here, mom donated a big T, dad donated a little t. The big T dominated the little t, so we have a tall offspring. The only way this person could be short was mom donated a little t, dad donated a little t, so we have a short individual. Pink dominates yellow. We have two possible genotypes for pink because it's dominant, big P, or big P, little p. And then for yellow body color, you have only one possibility because it is recessive, and that is little p. Please, if this is confusing you, go back and watch this video, email me, reach out to me, and let me explain it to you because this will come up again and you need to understand it. So then we get into actual Punnett squares. All right, and I'm going to go through two of these, and then I'm going to stop, and I'm going to have a Google form included here where you'll have to answer some questions. Let me back up and just read the question to start with. It says, SpongeBob SquarePants recently met Sponge Susie Roundpants at a dance. Well, that's just extra information. Who cares? SpongeBob is heterozygous for his square shape. So guess what, guys? Pick a letter, use it. I'm going to pick, well, they use S's, so I'll stick with S's. So that means that SpongeBob is big S, little s for his square shape. Let's say I didn't know what heterozygous meant. Well, I can go back to the second slide in this presentation, and it tells me heterozygous is big letter, little letter. Sponge Susie is round. Round is recessive. It doesn't tell you that, but it tells you to look at question 2. And if we go far enough back, question 2 says square is dominant to round, and that leaves round as recessive, little s. So we're going to go ahead to the question. Excuse me. Sponge Susie is round, so she's going to be little s. And it wants you to create a Punnett square showing the possibilities of what SpongeBob and what the possibilities would result if SpongeBob and Sponge Susie had kids. So our parents are big S, little s, crossed with little s, which looks like this. Big S, little s, crossed with little s. This is SpongeBob, and this is Sponge Susie. So I'm going to take this out of present mode for a second and insert a text box here. So our parents are big S, little s, and I like to write it out this way so it's not as confusing. I'm gonna, all right, so this is one of your parents. This is your heterozygous parent, SpongeBob, and that's what's across this square. And see, I don't like using S's because I can't tell the difference unless they're side by side and what's a capital S and what's lowercase. And then this is Sponge Susie down this side, little s, little s. Now I'm going to bring this S down here, this little s over here. As you saw in that one video, it's always good to put your capital S first. Over here, I'm going to bring SpongeBob down to the side, or excuse me, SpongeBob straight down, Sponge Susie over. I'll have little s in this box. Big S comes down, little s over, big S, little s in this box, and then little s in this box. So it's wanting us to list the genotypes. Now, I only have 2 genotypes. I have 4 squares down here, but there's only 2 different genotypes, big S, and little s. Oh, God, I sound like I said a cuss word. I didn't. And then their phenotypes are square right here. Big S, little s would be a square shape because that's what's dominant if you have a big S. And then little s would be a round shape. What is the chance their child would have square shape? That would be these 2 out of 4 boxes, which would be 50%. And what are the chances this child would have a round shape? That would be these 2 out of these 4 boxes, and that would be 50%. All right, let that soak in for a second. I'm going to go to one more question for this particular set of slides, and then I'm going to stop, and then I'm going to put a Google form up to ask you some questions about this. This is what we're going to focus on next week when you guys come back in class. Juniors would be the following or 2 weeks later, but we're going to focus on this stuff. Our next question is about Patrick and Patty. Patrick and Patty met at a dance, and they're both heterozygous. So for that example, they're going to both be, and I'll escape out of here, and they're both going to be well, if I can find a place to write. Let me put it down here. In this case, both of them are going to be, oh, I hate P's. They look the same too. Big P, little p. I always use T's, like I said. Big P, little p. Both are heterozygous. I shouldn't say hate. I strongly dislike. Big P, little p, big P, little p. And that's the parents' genotypes. So Patrick is big P, little p, and Patty is big P, little p. And their genotypes are down in the bottom left corner. So Patrick, big P, little p right here, and Patty, big P, little p right here. And then I'm going to put their genotypes in the boxes. So big P in this first box, big P right here, little p right here in the second box. Always put your big P first. Big P, little p in this box here, and then a little p right here. Now, in this situation, 3 out of 4 of your possible genotypes of your offspring are going to have the trait that is the most dominant, which is pink. And 1 out of 4 would have the yellow trait, which is the recessive trait. So I list my genotypes, big P, big P, big P, little p, little p, little p. I list my phenotypes, which is what they look like. I don't have to give percentages here, pink and yellow. What are the chances of having a pink body? 3 out of 4, or 75%. What are the chances, it says, of having a yellow body? 1 out of 4, or 25%. I know I flew through that one, so you can replay the video at this point. I'm trying to keep the video short, but I'm going to ask you some questions on a Google form that goes with this video. So stay tuned for that. I'm super excited to get you back next week so I can see your faces and we can work, and bring a notebook. If you don't have one, I'll have one for you. That's a spiral composition book. Also, no Zoom this week because we're going to see each other soon, and I'll be able to catch guys up. If you need to know if you're A-Day, B-Day, look on your report card. If you didn't get a report card, email me. I will tell you. Classes are very evenly balanced. There's about 10 of you on each day, so that's good, and I have individual desks for each of you. Remember to bring your mask. You will have to wear one, so just make sure you have that with you, and I look forward to seeing each of you. I'll put the Google form up and possibly one more video, and that should be it for this week. See you guys soon.